Have you ever listened to a rapid native English speaker and wondered where the actual words disappeared to? On the page, written English is a series of strictly separated blocks. We assume we speak by reading those distinct items aloud, one by one. But natural conversation outputs a continuous ribbon of acoustic energy, where the boundaries between words constantly overlap. This blurring of words is a systematic, rule-governed biological efficiency mechanism. Spoken language operates as a specific physical output called connected speech, a continuous stream of sound that lacks basic word boundaries. The primary barrier to understanding native speakers in rapid conversation is the physical melting together of adjacent sounds. Linguists call this structural ambiguity juncture variation. In rapid speech, the phonetic pauses between words are completely obscured. This animated data comparison shows two identical acoustic sound waves side by side. One captures the phrase great ape, and the other is gray tape. When spoken fluently, these two drastically different phrases are physically and acoustically identical. There is zero measurable difference in the waveforms. Without conversational context to guide you, the raw sound of fluent English is a purely ambiguous signal. To make sense of it, you have to rely on an organ far more powerful than your ears. Pronouncing every distinct consonant and vowel requires massive muscular energy. The human mouth has to coordinate lips, tongue, vocal cords, and lungs with millisecond precision for every single syllable. To prevent physical exhaustion, the mouth employs an energy-saving mechanism called phonological reduction. The first rule of this mechanism is linking. When a word ends in a consonant and the next begins with a vowel, the consonant slides over and attaches directly to that vowel. Next is assimilation. Adjacent sounds physically change their features to mimic their neighbors, smoothing out the transition for the facial muscles. Under elision, the mouth completely drops complex consonant clusters to minimize peak muscle strain. Entire letters simply vanish from the sequence. This block diagram shows the 8 words of "I'm going to get a cup of tea" isolated into perfect segments in formal citation form. But the compressed reality of the spoken sentence sounds like a unified vocal gesture, "I'm gonna get a cup of tea." Because the mouth deletes up to half of the expected acoustic data to save energy, the listener's brain is forced to do double duty to recover the missing reality. The human brain hates missing information. When faced with acoustic gaps, it automatically reconstructs incomplete speech before your conscious mind even realizes it is missing. Cognitive models map this out as a multi-stage pipeline, contrasting the slow, bottom-up decoding of raw sensory sounds against the rapid, top-down construction of meaning derived from context. In 1970, researcher Richard M. Warren demonstrated this with the phonemic restoration effect. He exiled a phoneme from a word and replaced it with a burst of white noise. Listeners reported hearing the missing sound as physically intact. The biological mechanism driving this is predictive coding. The auditory cortex uses frequency-specific neural oscillations to actively synthesize missing acoustic energy in real time, matching the incoming signal against top-down templates. But this illusion has a strict physical limit. If the missing sound is replaced by pure silence instead of noise, the acoustic interruption is immediately detected, and the brain fails to restore it. We are not intelligently guessing at missing syllables. Our biological predictive engine forces us to physically hear words that were never actually spoken. This explains why listening to rapid English is so exhausting for language learners. Their working memory is entirely consumed by the bottom-up acoustic decoding of a messy, reduced signal. A native speaker's brain has highly automated its top-down predictive coding. It instantly fills in the blanks without triggering any conscious effort. This dual bar chart compares neural activity in the superior temporal gyrus. It reveals a counterintuitive neurocomputational finding. Hearing messy, reduced speech actually causes brain activity to decrease. Native speakers do not notice missing words because their brains perfectly predict the gaps. This results in zero prediction error, which allows the missing data to bypass conscious processing entirely. True mastery of a spoken language is defined by the recognition of structural patterns hidden beneath the noise. Fluency begins when a listener's brain stops searching for every letter and learns exactly where English hides and drops its words. Spoken English operates as a collaborative illusion, where the speaker's mouth and the listener's brain work together to construct meaning from shadows.